Good day, professionals, and welcome to another class of quantitative analysis. Today, we shall be discussing what we call sampling techniques. Yeah, when we say sample, what do we actually mean? What are we sampling? And is there any techniques or method of conducting that sampling? Let us quickly examine that. When we have a large number or a large size of a data, when the data that we actually want to carry out is too much, we usually carry out what we call sampling, or let us take a sample. Let's go slow. If you want to buy something in the market, you would have already gotten the specimen, the look-alike, which you call the sample of what you want to buy. Is that not? If it is not what you can recognize easily, like to avoid color differences in terms of a cloth or whatsoever. Likewise, if organizations engage in large transactions, they have a large files, they have a large document, and they're like, how can they actually analyze this data? Remember, we said quantitative analysis is more all about a data analysis. So when you want to analyze a data that involve large data, that involve large size, that's what we call, you will take what you call sample. The sample that you are going to take will not serve as a representation so that we could make an informed decision. The sample at times is enough for us to predict about the outcome of an event. So when we say the sampling techniques, we are talking of, it's one of the important tools or method that we use when it comes to what? Analyzing our data. Likewise, it's part of the population that we study, and we use it to actually make informed decisions. In discussing sampling techniques, we must first of all look at some of the terminologies we use there. Which one of it is population? Population is the numbers of people. Population is the numbers of size. Population is the numbers of items. Population is a numbers in a group. For example, the number of commercial banks in Nigeria is population. The numbers of staff in a commercial bank is population. The numbers of students in ICAN Online is population. The numbers of children in a family is a population. So population is the collection or a group of items that is satisfying a characteristic or that are related to characteristics. When we say related to characteristics, we mean that are related to recognized items. For example, a group of people in a family, a members of a nation, a class of a particular area. That's what you call what? Population. So this population can then be further be classified into human being, animated, inanimate, and also a given population like a candidate in HS students. A candidate that is writing HS exam are referred to as what? Population. Excuse me. Obviously, there are just two types of population, which we call finite and infinite population. When we say a finite population, we mean the population that we can actually count, like numbers of items, like children in a family. How many children? 1, 2, 3, 4, 5. We have 5 children. 5 children in a family, that's a number. What is the numbers of staff in a bank? 25. That is called finite population. Do we get that? And the other one that cannot be counted is what you call infinite population, or we call it infinite population. That is the population of students in a college. That one is an example of a finite population, and the particles of a beach are infinite population. Like if I tell you that the population of sound, can you count sound? No. Population of water, it cannot be counted. Population of hair cannot be counted. That is just as we have finite verb and infinite verb. Okay. I haven't talked about population. The other thing we are going to, the other element that we shall also talk about is sample. There's no way we will be talking of sampling techniques that will not talk of population, sample, and size. These three works in pari passu, and they must be treated as such. When we talk of sample, a sample I've selected to observe. That's why I said when an item is being selected to use to form a decision, we call it sample. For instance, we want to know the population of students that are writing ICAN in a year. Can we actually determine that? Yes, we can. We cannot count the students one by one, but do you know that you can actually take a population to form our decision? Okay, using the population of last diet, 25 students registered for ATSWA, 175 students registered for ATS2, and 201 registered for ATS1. So this diet, we should be expecting 50 for ATS3, 140 for ATS, altogether 75 students. Because we were able to take some samples. Samples is just as if I'm telling you example of. When you are taking a sample of an object, a sample of a data, a sample from an observation to form a decision, we call it sample. That thing that is being taken is just an element or a fraction part of that population. Like, I want to know whether your family is good or not. I need to observe just one person among you. If I should judge you, judging you can make me to form opinion on your family. The family of Kasali are so good because your might is nice. Can you see that? You are only taking one person. That person you've taken is called a sample. And you are using it to form your opinion on who? On a group. I hope that is clear. After that, I move to what? Census. Census is just the total of the population. Just as, you know, something is common in Nigeria. What is our population census? Census is just what? The total units of the whole group. Like year 2006 populations in Nigeria. Head count of Nigeria in year 2006. The total numbers of students sitting for March 2022 diet ATX exam, ATSWA. Another one is a sample survey. When we say survey, survey means when you collect part of the information to observe. So a sample survey is just a method of collecting information by the use of a what? Fractional part of the what? Population. When you take a sample, remember, that a sample is when you just pick a fractional part out of the whole group to form your what? Observation. I mean, to form your what? Decision. If you now use that sample that you've taken, you evaluate it, we call it what? Surveying, sample survey. Survey means to observe. When I tell you, go and survey that thing for me, I'm telling you that you should make your what? Observation, research, your knowledge on that. So survey simply means what? Observation. Sample survey means taking a fractional part out of the whole group and you make and you observe them. That's why I said when I take a candidate in ICAN to actually survey the outcome of others. That's that. So we have sample frame, we have population sizes. When we talk of size, size is just the numbers of people in that what group. And sample frame, that one is just when we targeted some selection of the samples. Like, I want to carry out a research, or let me say, I actually want to make a decision, a recommendation to ICAN on why students are failing some courses, some subjects, some papers in ICAN examination. I don't have to meet all those people that have failed. I don't have to meet them. I only need to meet some certain people. But what is my sample frame? My sample frame is those people that fail. No, don't let me use that. I want to know the rate at which people passes ICAN exam. So my sample frame is what? People that passes ICAN exam. Then that is my population, actually. That is my population. My population is the numbers of people in a group that I really want to use for my observation. Now, am I having some specification to the level of passes? If the answer is yes, okay, let me say professional students in the whole ICAN exam. So my sample frame will now become what? Professional students. Is that taken? And the sample can actually be taken. Oh, hello, good afternoon. How are you doing? Yeah, you pass your ICAN exam. Can I know the secret of passing? Is ICAN that hard? You tell me my opinion. I go to another person to collect opinion. That is my sample frame. Sample from the what? From the frame. Within, I'm taking a sample from a particular levels. Yes, when we are now taking a sample, when we are doing a sample analysis or a sampling techniques, we usually use n divided by n. Function of n divided by what? N, in which the big N is the total population and the small n is the sample size that we are taking. When we get to an example, we shall be examining this in a broad sense. Likewise, sampling techniques can actually be broken down into two types. We have probability sampling method, and we also have purposive sampling method. When sampling method, when the outcome cannot be totally predictive, we can only predict, it cannot give us the accurate answer. That is what you call what? Probability. I'm only making what we call opinion. Purposive is when I'm actually targeting results out of the observation. So the probability sampling method itself is a method of a random selection. Probability use random selection. And we do it in such a way that each unit of the population will have a chance. That's how we said probability is a game of chance. Each unit, each member, each person in that sampling method will have a what? A chance of occurrence. And the different method we have systematic, we have stratified, we have multi-stage sampling method of what? Probability. The other one is what we call, each of these can be discussed, and you already have that in your notes, so you can just go through them. We have simple random sampling. That simple random sampling is just when every member of the population we are given equal chance to be selected. They have equal chance of occurrence. For example, if you go to a place where they are doing, those people that are playing visa lottery, you will see that they all have equal chance of either winning or losing. ICAN exam, you all have equal chance. So far you are registered, all of you have equal chance of passing or failing. So far you meet up with your what? 50%, you pass. 49.999, going nowhere. That is what you call simple random sampling. When a members of a unit, or when a size is being selected with what? Equal preference. That's what you call what? Simple random sampling. Take note of that. We have its advantages and its disadvantages. Another one is systematic sampling. When we say systematic sampling, this one, not that everybody do not have equal number, but the size is selected systematically. We select the size from the population systematically. Everybody were not actually given the equal chance, like that of the simple random sampling. Yes. And the method also demands that this sample frame is available for selection, and it is available serially. When I say serially is, for instance, I'm having my number 1 to 20, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 20 like that. And each unit of the item will be selected according to the word system. You are not picking it randomly. It is the system. We use systematic way of what determine it. Let's take, for instance, in a population of 120, we have what? 15 samples. When you have 50 samples out of the population of 120, the first thing is we have 120 and we only have a size of what? 8. You first of all divide 120 by 8. You divide 120 by 15 because you're having 15 sizes, and that will give you what? 8. Since that has given you 8, it means the one that will precede the another one should be what? An interval of 8. Should be within an interval of what? 8. If I selected a numbers of 5, systematically the numbers that will follow that 5 should be what? 13. Because 5 plus 8 will ultimately give you what? 13. After 13, the one that should follow should be what? 13 plus 8. And that will ultimately give us what? 21. After that, the one that will follow will also be what? Plus 8. Because the system has generated that the interval, the system has presumed that the interval that should be between the number should be 8. That is why if you look at how all these okay, let me talk of that Glow Reward promo that the Glow were earlier. During the time of Glow Reward promo, I think you're aware of that Glow Reward promo. When Glow were doing their promo and doing their, we charge 500 naira to. We charge 500 naira and get a chance to win gifts. how we then now select that? They will tell you that, how did they put it? The winners will be selected systematically. Initially, at times they use the output draw. At times they use the systematic ways of selection. When they use the systematic, if they have been that, if they selected a digit that ends with, let me say 6263, the total number that they have is this, and they only have 15 gifts to give. They will now divide the total number by the 15 gifts. That will be giving them the numbers of people to select. You now say, okay, these people that you are going to select, we will not just select them serially. No, we are going to select them systematically. And in order to achieve that, that could only be achieved when they have a number that will actually presume the rest, just as the case that we have cited. I will talk about systematic sampling. Another one is what we call stratified sampling. When we say stratify, that's what I usually use, is strata. When we say something is strata, it means it looks alike. It is heterogeneous. Okay? When we say something is heterogeneous, means it does not look alike. And it's a method that we commonly use in a situation where the population are not synonymous. Synonymous means they are heterogeneous. Heterogeneous in the sense that they are not related. All students writing ICAN are what? Homogeneous, because they are what? Synonymous. ICAN and medical examination a whole and law schools, they are heterogeneous because they are not similar. But ICAN and ACCA are what? Homogeneous because they are similar. I hope that is clear. So when we selected an items based on what? Heterogeneous, we are using what we call stratified sampling. We are using a method of strata. And where do we use a stratified sampling? We actually use it when it comes to income level, when it comes to the employment status. That's how you see that they will advertise a position. When they advertise a position, and they will tell you that all qualification is required, whether you study banking and finance, you study accounting, you study management, irrespective. And your ethnics, irrespective of whom you are, whether you are black, you are white, you are albino, you are this, you are that, you'll be selected if you're qualified. Whether you are male or female, you'll be selected if you qualify. So far, you have the qualification. So in that regard, we use what you call stratified sampling. Another method is what you call multi-stage sampling. Multi-stage, when a sampling is being conducted stage by stage. Stage by stage in the sense that when you pass the first, okay, let me use a sample of those people that, when you want to process your admission, you go by stage, right? When you are processing your admission. The first thing is, when that admission, you first collected your JAMB form. After the JAMB form, you must have scored a required score before you can apply for post-UTME, and you must have also selected that school. Let me use a practical sample. Universities of Lagos advertise that all JAMBites should apply for their post-UTME, but you must have scored 200. First stage, you must have scored 200 in your JAMB. Second stage, you must have selected Unilag as your first choice. After writing the post-JAMB, you need to be offered admission. After being offered admission, you need to have complete your data profile, go and submit your records to students and do your registration. That is what we call multi-stage, when a sampling is conducted in different stages. We have cluster, when we group everything together. That's what we call cluster. And non-probability sampling is when we just use ordinary judgment. We are not conducting any techniques. We are not using any method. We are not using any ways of determining our observation. We are just using our what? Intuition. We are using our judgment. That one is non-probability sampling. And my dear professionals, it exists. We also have quota sampling too, which is just an investigation that we conducted in order for us to balance some categories of population. Okay? Yes, we have talked about the summary in our last class. So, having discussed about the different types of sampling that we have, using the probability and the different types of the probability that exist, we shall be going to some calculatory aspects by starting from what we call measures of location. When we say measures of location, measures of location is actually a way by which we measure and analyze our data. So measures of location is just the summary statistic, which is concerned with the figure that is being represented in a series of value. And it can be categorized into measure of average, or what we call measure of central tendency. And we also have the second one, which we call measure of partition. When it comes to measure of average or measure of central tendency, measure of central tendency includes all our measurement using all the statistical tools such as mean, median, mode, and the likes. Okay. So the measure of central tendency is actually the average value, which will represent a value in a group of data. And it is typically tends to lie within the set of data as we arrange it in order. And the common useful one that we use what we call mean, median, mode. That is the most three measure of central tendency that we use. Mean, median, mode. Okay. The mean, median, mode are the three measurements that we use to measure location and data statistically. Okay. So let us observe let us observe them one after the other. The first one is what we call arithmetic mean. And when we say arithmetic mean, we mean the summation of value in a data, whether group or what, on group, and then divided by the numbers of that data. If it is mean, if it is arithmetic means of on group, it should be summation fx over what? Summation f. Or we use summation x1 over what? N. Irrespective. Summation fx means where f addition the numbers of its occurrence divided by the what? Divided by summation x1 over n is where this called summation, the x is usually in numbers. The total numbers is the number of between the total numbers and the numbers in a value. Okay. Do we get that? All right. mean is denoted by this X bar. We use X bar actually denotes the mean. Now, let us examine example under them. Okay. From the unlisted data generated on the numbers of sales of cement in bags, we have 12, 13, 17, 14. We are asked to determine, okay? Data, we are asked to calculate the mean. First thing that we're going to do, you will add up all the numbers that are given. We have 12 plus 7 plus 2 plus 6 plus 13 plus 17 plus 5 plus 9 plus 4. You now divide it by so when we are working with measure of central tendency, you have to look at the mean, the median, and the mode. And when we are working on the mean is just, as we said earlier, is the summation fx over summation f. So taking the samples, let's take for instance that we are given the following data: 12, 7, 2, 6, 13, 17, 14, 9, and 4. We will add all the digits, we add them together and then divide it by what? By the numbers of value, by the total numbers of the value. Adding it together means that we are going to add 12 plus 7 plus 2 plus 6 plus 13 plus 17 plus 14 plus 5 plus 9 plus 4. And divided by what? The total number. By counting them one after the other. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? 10. That is 10. When you divide 89 divided by 10, you will get what we call 8.9. Approximate it to the whole number because this is bags. It will give us what? 89 bags. I haven't gotten that. It will give us 9 bags. I haven't gotten that. Let's go to another example. Example 2. From the data given below, is generated for what? Per liters of water. What is the mean? You are given 2.7, 6.3, 4.1. You will add all this number, you add them together. Add means you plus together. 2.7 plus 6.3 plus 4.1 plus 6.4 plus 3.5 plus 4.7 plus 30.8 plus 7.9 plus 12.1 plus 10.4. You now divide it by what? By counting the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's also 10. So when you sum it up, you will have what you called 719 divided 71.9 divided by 10, and that will give us 7.19. That is that for the what on group data. So let's look for the group data. This one is not even a group data. Oh, don't worry, I can call it a group data, but it's not a group data actually. This is just a data that occur more than one times. If you look at the previous one that we just examined, you will see that all this number 12, 7, and 2, all this number don't only occur once. All this number they occurred once. Let's look at for where the numbers, where the data occur more than once. Okay, how do we check that? So yeah, we are given a data that has already been collected from students that registered for quantitative analysis of some ICAN examination. And we are asked to determine or obtain the mean of that data. How do we determine that? X is given by the numbers of students. We have the numbers of students 1, 2, 3, 4, up to what? Up to 5. How many times is one student occurring? That is what you mean by F. This is number, this is frequency. Frequency means the number of occurrence or the numbers of time the data occur. Okay, one occurred in 8 times, 2 occur in 7 times, 3 occur in 10 times, 4 occur in 6 times, and 5 occur twice. So how do we do this? Our mean, we are using a mean of what? Summation fx over summation f. Okay, this and this, you multiply it together and then divide it by the what? To get fx and divide it by the what? By the number of the frequency. So yeah, let us go. Write your x. This is my x that I've written here. That's my frequency. I just have to overturn this. This is x. This is f. I overturn it. Okay. Overturning means I change it. This is my x, the x here. This is my f, the f here. Then x times f will give me fx. So let me write my number 1, 2, 3, 4, and 5. How many times does it occur? We have 8, 7, 10, 6, and 2. 1 times 8, 8. 2 times 7, 14. 3 times 10, 30. 4 times 6, 24. 5 times 2, 10. Now, let me add this together. 8 plus 7, 15. 15 plus 10, 25, right? 25 plus 6, that's 31. 31 plus 2, that is what? 33. So the frequency is 33. Then fx will now be what? 8 plus 14 plus 30 plus 24 plus 10 will give me what? 86. If I now divide 86 by 33, it will give me what? 2.6061. So 2.2061 is just the what? The mean of the numbers of the student. I hope that is clear, right? If you did not understand, just drop me a chat on the comment section. Okay, we are getting it. Good of you. So let us move further. Remember that in our last class, in our last video, we actually talked about class size and class boundary. Please, if you are missing that aspect, you can quickly go there to refresh yourself. This one, this sample here, will be making use of the class size and the sample, but it's still the same thing. Give it a class size of 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. With each having their what frequency, can we obtain the mean of that data? The data has been called the age of people that are living in an estate. Always write your formula first. The formula for mean is x bar equals to summation fx over summation f. Summation fx over summation f. So you will overturn the table, write your class, write the class, you find the word class size. This is the interval, or you call it class interval. X is the class interval, then the F is the frequency, and the Fx is there. 1 plus 10, 11, divided by 2 will give us what? 5.5. 1 plus 10 divided by 2. That is how to find the what? Class size or interval. 11 plus 20, that is what? 31 divided by 2 will give you 15.5. 21 plus 30, that is 51 divided by 2 will give us 25.5. 31 plus 40 will give us what? 71 divided by 2 will give us 35.5. 41 plus 50, that is what? 91 divided by 2 will give you 45.5. You've gotten your x. What is now your frequency? That one has already been given here. Multiply 5.5 by 6 with 6 will give us what? 33. 15.5 times 17. 25.5 times 7. 35.5 times 12. 45.5 times 6. And that will give us what? At the end of the day, sum up, add up your frequency, add up your fx. Then you will find the summation fx over summation f, in which the result will give us 1174 divided by 50, and it will give us what? 23.48. Because it is in year, just put what? Years. That is that about mean. I will know what's a mean of group data. This is group data. I will check mean of group data and that of the ungroup. Let us quickly examine what we call assumed mean. Assumed mean. Assumed mean, it is a mean by assumption. A mean of what? Assumption. That is what we call assumed mean. A mean of assumption. Okay. Going by mean of assumption, it is possible for us to reduce the volume of figure that is involved in the computation of a mean by the use of what we call assumed mean. And for the assumed mean, we will just observe the value of the class size that has already been chosen. Having observed that, we prefer to actually choose the middle one. Having chosen the middle one as the assumed mean, then we now denote it by what? A. That A will be standing for what? Assumed mean. Then we will now introduce a new variable D using the expression by having mean equals to assumed mean plus summation FD over summation F. Do we get that? Now, let us illustrate it practically. Let us use practical method. Okay. Look at the example below the explanation. Now, let us first work on that. Using the data in that example above to obtain the arithmetic mean by using 9 as the assumed mean. You know, I've told us earlier that we are going to select a number and call it what? Assumed mean. So here, we are taking 9 as our what? As our assumed mean. It has already been given in the question, so you don't have to bother yourself much. We have already been given 9 as what? Assumed mean. Okay. So let us go back to the illustration we were working on earlier and use assumed mean of 9 to solve it. So let us go back. This is the question. That is the class size. That is the interval. Let us now use assumed mean of 9 to solve. Okay. Yes, we are still using our class size of 1 to 10. Yes, I can see your question. Yes, that is what we are still using. Okay. So we have our summation. This is the question. Our question of 12, 7, 2, 6, 13, 17, and 21 respectively. That is the one that we are using. And do not forget that we have selected assumed mean of 9. So we write all the figure 12, 7, 2, 6, 13, and your D will now be what? You know, we've used assumed mean. Our assumed mean is 9. Let me put the assumed mean here so that we can get it right. This is our assumed mean denoted by A. That is 9. It will be 9 all through because that is what we are choosing. 12 minus 9 will give us what? 3. 7 minus 9 will give us what? Minus 2. 2 minus 9 will give us what? Minus 7. 6 minus 9 will give us what? Minus 3. 13 minus 9 will give us what? Plus 4. 17 minus 9 will give us what? 8. 14 minus 9 will give us 5. 9 minus 9 will give us 0. And 4 minus 9 will give us what? Minus 5. If you now add the D together, that D, if you now add it together, our summation D is equals to what? Minus 1. So to now find the mean of the assumed mean, we have A plus summation D1 divided by what? N. And summation D1 is minus 1. Divide minus 1 by the what? Divide minus 1 by 16. It gives us 9, it gives by 10. 1, 2, 3, 4, 5, 7, 8, 9, divide 10. It will give us what? 0.1. So 9 minus 0.9.1, it gives us 8.9. If you approximate it together, you will still be having our what? 9. So the mean value of that data is just what? Is just 9. I haven't worked on that. Let us look at another sample. to actually understand the assumed mean so that we can get it better. Now, using the data, the one that we're given of is 0.10, this data, using this data now, let us now use an assumed mean, because this one looks more or less like a group data, right? Since it is, let us use assumed mean to work on that. All right, we have a class size of 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, and the frequency is given as 6, 17, 7, 12, 8. Okay, so zero to 10. That's not the question I've used. This is the question on its own. Yeah, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. And the frequency is 12,8,776. And we are using the assumed mean of what? 25 years, which is 25. The assumed mean is what? 25 years. That is 25. So since the assumed mean is 25, first of all, you will find the class interval. Don't forget, when you're given your class size, this is class size. When you're given your class size, you need to find what you call interval. And your class interval is your x. Your class interval is your x. So is 0 plus 10 divided by 2 will give you 5. 10 plus 20, 30 divided by 2 will give you 15. 20 plus 30, 50 divided by 2 will give you what? 25. 30 plus 40 is 70 divided by 2 will give you 35. 40 plus 50 is 90 divided by 2 will give you what? 45. This is the frequency. So the frequency is what? Is 12, 8, 7, 7, 6, 7, 7, and 6. Is that not? Now, assumed mean is used with x and not with frequency. Don't forget. Assumed mean is used with what? X and not with what? Frequency. 5 minus 25. I can create a table here because of you and put A. And that A is assuming, it means it will be constant, which is 25, 25, everything will be what? 25. So 5 minus 25 will give you what? Minus 20. 50 minus 25 will give you what? Minus 10. 25 minus 25 will give you what? Is 0. 35 minus 25 will give you 10. 45 minus 25 will give you what? 20. Now, this F multiplied by the what? Assumed mean will give us what? Summation. Will give us FD, which you call, instead of having summation FX, it will now be summation FD. D being that what? Assumed mean. Okay. So if you multiply 12 by minus 20, 12 times minus 20, it will give us what? Minus 240. 8 times 10, 80, but it have minus 80. 7 times 0 is 0. 7 times 10, 70. 6 times 20, 120. Then our assuming will be what? A plus, assuming will be A plus summation FD over summation F. A is 25, which is that 25 years. FD is minus 130. When you add this together, minus 120. Our F is when we add this together, 40. So 130 divided minus 130 divided by 40, it gives us minus 3.25. Minus times plus will give us what? Minus. So 25 minus 3.25, that one gives us 21.75. Approximate it, it will give us what? 22 years. That is all about mean. Whether assume mean, group data of mean, or ungrouped data of mean. All right. Let us now go to the remaining two, which is mode and median. Median and mode. When we say mode, mode is the most occurrence number in a given set of data. The number that appear most in a data is called mode. We now have mode of group data and we have mode of ungrouped data. Likewise, it is important for us to know that one mode is called unimodal. Two modes is called bimodal. Two, everything two is called bi. One is called uni, like university. Okay, varsity, one varsity is university. Okay, if you want to say two, we say bimodal. I mean, if you want to say two, you say bivarsity. That's how we usually hear biannual. But anything by is two. So bimodal is two. And when it is much, we call it what? Multimodal. Is that taken? So for a group data with frequency distribution, the mode is being determined. Either we use what you call graphical method, or we use what? Histogram, or we can use the formula. Better, if you know that you cannot use graphical method to actually determine the mode in the frequency data of a group, you cannot use histogram, please just use a formula. You have a formula. And the formula will actually tell us the highest occurrence data, the highest occurrence number in a given data. Okay, we want to use a formula. The formula will be L1, which is the lower class boundary or lower boundary, divided by modal frequency before the modal class, and the sigma 2 will give us what? The modal class frequency immediately after the what? Modal class. And the C there is what? The modal class. Is that taken? L1 is the class boundary of the modal class. All right. That is mode. For median, that one is the number that is usually at the middle of a given set of data. If it is more than one, we divide it by 2. Let's assume that, for instance, I have 1, 2, 3, 4, 5. And I ask you which one is at the middle. Before you can determine the one at the middle, you have to arrange either in ascending order. From ascending means from lowest to the highest, or descending order, which is from highest to the what? Lowest. So let us choose 1, 1, 2, 2. You can see it remains just what? Just 3. And this one is ascending order. Let me say I want to arrange it in descending order. I will have 5, 4, 3, 2, 1. Let us find the middle. It remains just 3. Whether you arrange in ascending or descending, it will still be the same. Your median is the one at the middle of a given set of data. All right, but what I've just done is for the ungroup. For a group data, we have to use what we call ogive. We have to use what we call what? Ogive, or we use formula. Ogive is cumulative frequency curve, or better still, you can use formula. The use of formula will actually save us from the stress of ogive, because if you do not have your drawing sheet, or what do we call this? Your graph sheet, it might not that be much easier. So if you are using a formula method for the median, it is L1 lower class boundary plus open bracket n divided by 2 minus frequency 1. That is Fi. Fi is summation of all the frequency before the median class divided by F1, which is the frequency of the median class, then was multiplied by C, which is the median class interval. Let us go by example. Let us go by what? Example. Example 1. The following are the set of data generated from the sales of oranges within 11 days. We have 4, 7, 12, 3, 5, 3, 6, 2, 3, 1, 3. Which one occur most? Oh, calculate both the mode and the median. If you want to do the mode, first ask yourself, which one occur most? Check. 1 appear how many times? 1 times. 2 appear how many times? 1 times. 3 appear how many times? 1, 2, 3. 3 times. 4 appear how many times? 1 times. 5 appear how many times? 1 times, like that. So 3 is the what? Is the mode. If you now want to find the median, you first of all arrange, remember, if it is median of ungroup data, first arrange either in ascending or descending order. Okay? Arrange in ascending or descending order. How do you arrange in ascending order? Rearrange that number. We have 1. We have 1, 2, 3. How many 3 do we have? That is 3. 3, 3, 3. Okay. After that, we have 4. We have 5. We have 6. We have 7. We have what again? 8, 9, 8, 8, and we have 12. Can we find the middle? 1 year, 1 year, no, 12. 2 years, 7 years, 3 years, 6 years, 3 years, 4 years. Can you see? It remains just what? It remains 3 plus 2. As you can see, it remains 3 and 4 rather. As you can see, so just add 3 plus 4. That is 7. If you now divide 7 by 2, it gives us what? That is 3.3. If you round it up, the median number is what? 3. Okay. 3 is the median number. Is that taken? And If you don't want to do it like that, another way you can do it is from the number you are given, just count the number. How many numbers are they? Count. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10. Okay. Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 11. You will now add artificial one to it, making it what? Making it 12. If you now divide 12 by 2, it will give you what? 6. So if it gives you 6, so the 6 data, that set of data will be categorized as what? Median. So let's count. Okay. So 1, 2, 3, 4, 5, 6. This is the 6, which means 3 is what? Is the median. So do the rest for the one that we have done too. Now let us look at the group data for that median and mode. Okay. Use the graphical method to determine the mode of the following data. Range 2 to 4, 5 to 7, and you're given the frequency. The first thing is find your class size or boundary. To find it, you know, we need lower class boundary and upper class boundary here. So just reduce. To reduce the class boundary, -5 here, -5 here, and plus the 5 here. So that we have 2.45. Okay. If you now add 2 point, you will have 2 point. If you minus 0.5 from 2, it will give you 1.5. So if you add that 0.5 to the 4.5, it will give you 4.5. Minus 0.5 from 5 will give you 4.5. Add that same 0.5 to 7, you will get 7.5. Then put your frequency. Okay. Now, we want to draw the class boundary. Where can we get that 3? So, we want to get, if I ask you the mode from this data, which one is the highest frequency? 6 is the highest frequency, as you can see. So the mode is between 8 to 10. Is that taken? The mode is between what? 8 to 10. You can see it's between what? 8 to 10. Since the mode is between 8 to 10, that 8 to 10 is 7.5. The class boundary, 7.5 to what? 10.5. This is the 7.5 to what? 10.5. You first draw your graph, your frequency from 1 to 7, the 1.5 to 4.5. will give us what? This is it. Let's say this is 1, 2, 3, 4, like that. This is 1.5 to 4.5. What does it give us? It gives us 3. Put it like this. From 4.5, it moves to what? 7.5. And the 7.5 is what? 4. 4 is above here. So it will be like this. Okay. So I haven't done that. After doing it, you know that your mode is between 7.5 and what? 10.5. To not get the perfect mode, you just draw your line here and do another one to join here. Where this line intersects is called the what? Your modal place, which and the mode is what? 8.5. Okay. From here now, let us now use a formula. We have another data which we call class interval and class size. From 2 to 4 up to what? 10 to 12. You know that you have to draw your what? Frequency. And you have to have your what? Class size. 2 plus 4, that is 8, divided by 2. You have your class size that's supposed to have. Okay. Oh, we have already been given class interval. You are not given the class. Suppose you are not given, you will find out, but you are already been given the class interval. So from the class interval, now find the mode and find the what? Find the mode and find your mean. The mode means the most occurrence, the one that appear most. 7 year appear most, and it's fall between what? 8 to 10. Since it's fall between 8 to 10, 8 becomes what? Lower class boundary. 10 becomes what? Upper class boundary. And 7 becomes what? Modal class. While 20 becomes what? Frequency separation. So, using your formula, L1 plus, if you like, you can use changes 1 over changes 1 plus what? Changes 2 multiplied by what? C. And if you like, you can use F1 and use F1 plus F2 as you like. Okay, no penalty in doing that. So what is the class boundary? Lower class boundary is what? 8. Here will be 8. What is the modal frequency? Modal frequency is 7. This is it, 7. This is 8. That is 7. Okay. Frequency before the modal class, that is 6. Okay. This is 6. Frequency after the modal class, that is what? 2. 7 minus 2 will give us what? That is 5. After getting that, you will now, what is the class size? The class size is the class interval rather, is the difference between the two. 8, 9, 10, that is 2. So after that, now use the formula to solve. Okay, this is 1, this is 5. You have 7 minus 1, 7 minus 2, 7 minus 6, 7 minus 1 rather. So 1 plus, you have L1 is 8 plus frequency before the modal class, which is 7 minus 6. This is 1 over 1 plus 5 times 2. That's just it. Okay. 1 over 1 plus 5 times 2. So 8 plus 1 over 6 times 2 give us 1 over 3. So 8 plus 1 over 3, it give us what? 8.33. To find the median class, just use a formula as well. When you use a formula, you get a median class of what? 7.3. That is that for group and ungroup data. Any question on that? And the second illustration is available for you to practice. Any question? If there's no question, since there's no question, let us move to the second aspect of measures of location, which I call measures of partition. And the measure of partition has to do with quartile, percentile, decile. That is the three methods of partition that we have. When we say the measure of partition, we mean that it's a method of computation. It is a method of computation in which actually follows the procedure like that of the mean, median, mode that we have just examined. But here, when it is when it is quartile, we mean quarter by 4, decile by 10. That is quarter is 3n/4. Decile is 7n over what? 10. Percentile, that one is 10 of what percentage? Do we get that? So, and the formula that we use for each of them are as follows. When we are talking of quartile, for quartile, quarter only have what? How many quarter do we have in a year? Actually, some say 3, some say 4. What we want to know is I is denoted by what? By 3. And we have lower class boundary plus open bracket n divided by 4 minus frequency divided by what? Frequency. The big frequency, that one is the sum of the frequency of all the lower classes that are than that one ith quartile class. The same thing for the decile, the same thing for the percentile. The only difference there is when you are measuring for quartile, you use 4. Decile is 10. That is 10 decades before we have on the decile. Percentage is in 100. That's what you call percentile. Let us look at illustration to quickly wrap it up. Identify the what? Q1, Q3, D7. Q1 means find the first quarter, find the third quarter, find the 7th decile, and find the 20th percentile for the following data. You are given your interval, you are given your class, you are given your frequency, you are also given your cumulative frequency, and you are given your what? Class boundary. All right. So let us find the first quarter, which we call quartile. The first quartile, that one is just Q1. Q1 is what? 1Q. Q1 is 1N over 4. 1, this is my 1. 1N over 4. Okay. So what is the position of the 1N over 4? What is the numbers of the figure? The numbers is here frequency, which is what? 20. 20 divided by 4. 1 is just 1. 1 times 20 would have given us what? 20. 1 times 20 will give us what? 20. So 20 1 times 20 is 20, and 20 divided by 4 will give us what? 5. Okay, now, where can we get that 5? Where is 5? You now come here to the class. When you come to the class, so this is it. The class, this is 3 to 5. So K1 class is what? 3 to 5. That is the class. Is that taken? Since you've now gotten the class of the Q1, now use a formula to actually find the what? The quartile 1, called the quartile. So L1 plus open bracket n divided by 4 minus summation of the whole frequency divided by what? The frequency. Then multiply by class size. So what is the lower class limit of 3? Just remove 0.5. It will be 3 minus 0.5. The upper class limit, we are going to add 0.5 to the 5. So 3 minus 0.5 will give us what? 2.5. That is the L1. N divided by 4. We've gotten that to be what? 5. So that is 5. So what is the frequency of that class size? The frequency is what? Is the frequency before the summation of the frequency is what? Is 4. And the frequency itself, the summation of the frequency is 2. And the frequency itself is what? Is 4. And what is the class size? The class size is what? 3. Okay. Now, put everything into table. You will get what? Into formula. You will get 4.75. I hope that is cleared. Let's go to the Q3's position. To find the position of Q3, just have 3n divided by what? 4. That is 3. N is given as 20 from here. So n, so 3 times 20 will give us 60. 60 divided by 4 will give us what? 15. Now, that 15 will fall in which position? Where can we get 15? After 14 years, cumulative, we are going where? 15 will be under this 18. So the class size is what? 9 to 11. So since 9 to 11 is the class size, what is the lower class boundary of the F11? 9. What is the lower class? 9 minus 0.5 will give us what? 8.5. Okay. Then put everything into formula. You will get our 9.12. To find D1, decile. To find D1, you have n divided by 10 minus the same thing. Don't forget, they are all the same thing. So if it is 1 that you are looking for the D1,
our n is 20. 1 times 20 will have given us what? 20. So for the D7 will be n is 20. Multiply 20 by 7. 20 times 7. It will be 20 times 7 minus summation before the what? Frequency, and then the frequency. Okay. So 20 times 7 divided by 10 give us what? 70 divided by 20 times 7, that's 140, divided by 10, 14. Where did 14 fails? Go and check where the 14 fails. See, this is 14. 14 is in class size 6 to 8. Interval of 6 to 8 is where 14 fails. This is 14. So the class size is 6 to 8. Lower class limit will be 6 minus 0.5, which will give us what? 5.5. And the frequency is 8. The frequency before this 8. Summation of the frequency before the frequency. That's what I call this big. 2 plus 4 will give us 2 plus 4 will give us what? 6. Okay, that's how I was able to get this my 6. Then the small f is the frequency, which is 8. And the class size is 8.5 minus what? Lower class limit, 5.5. That will give me what? My 3. Put everything to formula, it will give us 8.5. Do the same thing for the percentile, and that is all. My dear professionals, it's interest us to know that the measure of location consists of mean, media, and mode. And we have considered both, even using the group and ungroup data. Likewise, we also measure the location using quartile, decile, and percentile, as discussed above. These are one of the important questions that I can like to use in an examination. Do endeavor to ask questions where required and go through the video once again. And where there's any ambiguity or you need further clarification, do not hesitate to contact us through our official page and through the what? Through our WhatsApp platform. Thank you. Any question? I wish you good knowledge, retentive memory, and best of luck in your examination. Ask question. Question time. Any question? Where there's no question, I would like to continue from here in our next class. Thank you and have a wonderful day.